Here I am with another question from hashing series. The question for today is top k frequent elements. The question says we are given with an integer array nums and integer k. Written the k most frequent elements. You may written the answer in any order. So this is the example that we have, and k is 2. The two most frequent element in the array as it's visible is 1 because it arrives 3 times and 2 because it arrives twice. So the output will be 1 and 2. Here we have, in the second example, we have 1 as our array, only one element, and k is also 1. So the answer will be 1, of course. Here in the third example, we have nums with so many elements and k is 2. So how many times does the 1 come? 1, 2, 3, 4. 4 times. So this is one of the element and 2 appears 1, 2, 3, 4 times. So the frequency of both 1 and 2 is 4. So the most two frequent elements in the given array is 1 and 2. I hope you understood the inputs and the outputs. We can learn it in more depth from here. Let me erase all this. To solve this question, we'll be using two main data structures. One is HashMap, where we'll be storing the frequency of the numbers, and the second is Max Heap, in order to find which element should be popped out first. So let's begin. These are the input values that we are given with. We understood this just by reading the question. And the second step is to calculate the frequency of the array elements using a hash map. So our hash map will be storing the number, that's the element from the array, and its frequency. So I hope you understood why is it 3 to 1. 1 appears 3 times, so it's 1, and 2 appears 2 times, so it's 2, and 3 appears once, so the frequency of 3 is 1. Then we'll have to create a max heap. Now, what is a max heap? Max heap is basically the root element of the max heap will always have the maximum frequency. Okay, max heap rules says that the element with the highest frequency is always at the root. This has to be remembered. This is the point of confusion. Most of the people get confused over here. The entire heap need not be sorted. Only the root contains the maximum value. Rest, it can be in any order. It doesn't matter. This is a really very important point to be made a note of, because at most of the time we get confused over here. Only the root is guaranteed to have the maximum frequency. Then we need to extract the top k. See, the idea is when you store some elements in the max heap, you very well know that the top element will be the maximum frequency wala element. The rest may be in any order. Once you pop the top element, soon the next top element will be made as the first element of the max heap. So it's for sure that the top element of the max heap will always contain the maximum frequency. Extract the top k. First we just pop the first element, that is 1, which is having the frequency 3. Then we go for the second element, that is first when we poll, we remove 1 because the frequency is maximum for 1, right? So our answer will be this. Then our heap reorganizes and 2 comes to the top of the max heap because the frequency of 2 is greater than 3, right? So the second pole will remove 2. The answer will be this. Now let's move on to the algorithm. Here in the algorithm part, firstly we have to create the hash map to calculate the frequency. Let's start coding. Both the data types that we will be using is integer. One is for the array elements and another is for the frequency. Let's name it as map is equal to new hash map. Okay, we created the hash map, and now we have to traverse the input array, store each number and its frequency. Let's calculate the frequency. For int n from nums map dot put n comma map dot get or default. Zero plus 1. I hope you guys know how this function works. I have explained it in my recent last video on what and how it works. Now this does our job of calculating the frequency. Let's move next. Next we are supposed to create a max heap, compare elements using their frequency from the hash map. For that we need a priority queue let's name it as PQ is equal to new priority queue. And by default it's a minimum heap. So in order to make it max heap, we need to add extra parameters, that is a comma b map dot get b minus map dot get of a. This is our max heap. So the line that we wrote just now is a custom comparator. So when you do a comma b map dot get of b minus map dot get of a, this compares based on the frequency, not the actual number. So based on the frequency it compares and adds it to the priority queue, so we'll know which one is the top root of the max heap. Moving next we have to add all the unique numbers from the hash map into the heap. We'll be doing it using pq dot add all map dot get, no, it's just key set. Okay, this is how we get all the unique elements from the map into our heap. Now we need to poll the heap exactly k times. Each poll returns the current most frequent element. For that we will be using a for loop that runs from 0 to k. For int I is equal to 0, I less than k, I plus plus. I hope you understood this for loop. It's basically because we have to remove k elements. So the loop will be running from 0 to k. Now we have to create an array. Let's name it as ans is equal to new int of k, because we are returning only k elements in the array. And then we need to do ans of I is equal to pq dot poll, and finally return the ans. We have passed all the test cases. Now let's submit. Okay, crazy. We are done with this. Now let's talk about the complexity of the problem. So yeah, let's consider u to be the number of unique elements, and building HashMap will take big O of n. Building and adding to the heap will take time complexity of big O of u log u. So polling k elements will take this much of time. So overall it's n plus u log u. In worst case it becomes this. When we don't have unique elements, when all the elements in the array is unique, then we have this as the worst case. Space complexity is big O of u, considering only the unique elements that are being stored. That's all for today's video. Thank you for watching.